Welcome back, ladies and gentlemen, boys and girls. The days are getting shorter.
The nights are getting cooler.
The leaves are changing colors.
It's official. Fall is here.
That's right, fall is here, and fall is easily one of my top 4 favorite seasons of the year.
There's only 4 seasons.
And speaking of the leaves changing color, we're going to show you how using just a blender and some paper towels, how you can explain the science behind the leaves changing color that are so popular this time of year to your children. That brings me to my new favorite joke.
You're not going to do that on camera, are you?
What did one leaf say to the other?
What?
I'm falling for you.
Can you just go to the intro?
Part of the fun of this experiment is spending a lot of time outside with your kids, just observing the fall colors and how beautiful they are. Unfortunately for us, this year, instead of fall colors, nature gave us Hurricane Delta. So during one of the few quick respites from the rain, we ran outside and just grabbed as many leaves as we could. We ended up getting a nice haul of green, yellow, and red colored leaves to work with. Leaves are pretty fascinating pieces of nature. The veins you see in the leaves are like tiny real-life highways. They're carrying nutrients and molecules out to the leaves and back to the tree, back and forth all the time. Specifically today, we're going to focus on a couple of those molecules. And number one is chlorophyll.
Chlorophyll? More like borophyll.
Before we get into our almost too easy to be true experiment on chlorophyll,
We need to talk a little bit about the plant cell.
the plant cell is going to look something like this. It has an outer cell wall and a cell membrane to protect it. It has a nucleus, which is kind of the brains of the operation. Additionally, it has mitochondria, vacuoles, and chloroplast. And that is where we're going to focus today, because inside the chloroplast is where we'll find our chlorophyll. Chlorophyll's main job is to absorb sunlight, so we can use that energy from the sun to convert the carbon dioxide that we breathe out to the oxygen that we breathe in. And chlorophyll does an excellent job of absorbing all of that light. But keep in mind, the white light from the sun is composed of all the colors of the rainbow, as you can see from this prism picture here. So let's look at these two leaves for example, one green leaf and one fall colored leaf. As I mentioned, chlorophyll does a really good job of absorbing sunlight, and while that's true, it actually doesn't do that well of absorbing the green light that's part of the sun's light spectrum. So to better illustrate this, let's look at two examples of our sun in the summer and in the fall. In the summer, the sun shines its white light with all the colors of the rainbow down onto our leaves. And when we look at the leaves, what we're actually seeing is the green light being reflected by the chlorophyll because it does not absorb it. In addition to chlorophyll, the leaves also have a molecule called carotenoids that are responsible for yellows, oranges, and red colors. And in a coincidence of nature, the same molecule that gives the leaves the orange color in the fall is the same molecule that gives carrots their orange color all the time. So in the fall, when the temperature cools and the leaves aren't producing as much chlorophyll, the carotenoids take over, and they do the exact opposite. As you can see here, the carotenoids are very good at absorbing the green light, and they end up reflecting the oranges, yellows, and reds, and that's what gives us our beautiful fall colors. So in summary, as you can see, in the summertime the leaves have plenty of chlorophyll and therefore there's plenty of green in our forests. But as fall comes, there's less chlorophyll being produced and the carotenoids begin to shine. So for this experiment, we're going to use chromatography to separate out the chlorophyll from our leaf. Chromatography is one of the many methods that chemists can use to separate many molecules from a single mixture.
So we're going to need a blender, some paper towels, and a bunch of leaves.
Alright, so we spent a little time collecting leaves this morning. We have green leaves, oranges, yellow leaves. Who brought the Legos?
I did, yes,
Next, have your kids cut out some strips of either coffee filter paper or some regular paper towels you have around the house. Now it's time to start blending. So put your leaves in a blender and mix with some water. And when you're ready, get to blending. Once that's nice and blended, pour your solution into a glass or a jar. And you can repeat this step as many times with as many different colors of leaves as you can find. And then just rest your coffee filter paper or your paper towel in the solution and you wait about 24 hours. And here we have the results of our chromatography strips 24 hours later. On the right of each group are our paper towel samples, and to the left are the coffee filter samples. I think the paper towels turned out better. To me, what's interesting is our summertime green leaf blended mix was completely green, meaning there was a lot of chlorophyll present. But when you do the chromatography, you can see that the yellow and orange pigments of the carotenoids are there. Conversely, you can see our leaf in the fall clearly has stopped making chlorophyll due to the absence of green pigment being filtered up. We blended our leaves in regular tap water. I have a feeling you might get crisper results on your chromatography paper if you use rubbing alcohol. We didn't have any in the house, and I didn't want to go out in the storm to get any.
I love these lazy Saturdays.
But if you do this experiment at home with rubbing alcohol, leave a comment below to tell us how it's turned out. Alright, that's it for this week's video. We hope you're able to get this science lesson in before the leaves are all gone. And if you haven't subscribed to our channel, please consider doing so and tell all your homeschooling friends about us. We appreciate the support. And we'll see you next week.